But we're going to see how proportions apply to scale models of things. So my sons really like the Hot Wheels, you know, and those Matchbox Hot Wheels are drawn to scale. That means they're, well, for the imaginary vehicles that they have, but some of their cars that they draw are, if you were to expand that, if you were like to somehow get just an expansion of it, it would be a real car. That's because they're applying proportion to those models. So here's what I'm going to give you. I'm going to give you this scale, 2 centimeters to 1 kilometer. 2 centimeters to 1 kilometer. And I'll explain what that means by my actual drawings up here. Again, I didn't use this for this lesson, but I'm going to. All right, a centimeter is about that big. Can you guys show me a centimeter? And you're like, Mr. Ray, that's huge. You know, yeah, it's between my fingers, not the fingers. Okay, so 2 centimeters would be double that. Can you guys give me 2 centimeters? And it's 2.54 centimeters per inch. So can you give me an inch? And just go a little bit shorter than that. That's 2 centimeters. Okay, 2 centimeters. If I had a scale of 2 centimeters to 1 kilometer on a map, okay, that means what does every 2 centimeters represent? A kilometer. So I'm going to look at this length Z. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Approximately 8. Okay.
It was definitely 10.
Okay. 10. Let's go with 10 centimeters. And this is not, you know, we'd have to get a ruler to do that. But how many kilometers would that represent?
20 or 5.
So I have 10 centimeters.
5.
Would be how many kilometers? 5. Why would I need that? Why would I need to know that? Well,
Maps.
do you guys use maps at all?
I do.
Miss Burrow's room, if she has a map, I'm guessing, right?
Yes.
And there is a scale there. It's not 2 centimeters to 1 kilometer per se, but it might be like 1 inch to like 500 miles. I don't know what it is, but I want some of you to find that out when you get the chance. And the reason we do that is because instead of drawing the whole planet in real life size, which would be how big? The whole planet. It'd be a blanket over the planet. Instead of doing that, why don't we shrink everything in proportion so you can see the whole world on one whiteboard or one wall, right? Isn't that convenient?
Yes.
No, I like the blanket idea. Okay, good. Yeah. So here's one scale here. And so I need to determine which one is the model. In this case, it's our map. And which one is the actual. Which one's the model and which one's the actual. Now, I hope you realize, in this case, that on a map, 2 centimeters is the model and 1 kilometer is the actual. So these 2 centimeters is actually 1 kilometer in real length. Okay, you guys get that right now? Just that they're 2, model, actual. Okay, so I'm going to give you a problem here to see if you can figure out what to do. I'm going to go to the next page. I'm going to rewrite my scale. That is a ratio. What's a ratio again, guys? A comparison of 2 numbers. So right here, I'm going to draw my fraction or my ratio of 2 centimeters for 1 kilometer. And then I want you to tell me, if I had 3 centimeters on a map, how many kilometers would that be? Don't work it out in your head.
1.5. Sorry.
That's okay. I'm going to set up a proportion to figure that out. Now, should the 3 centimeters go on the top or on the bottom? And it matters. On the top. Because on the top you want to put, and look, write this down please, you want to put the model, and I'll put model size because it could be distance or like weight or something like that. Model size over the actual size. Now, does it have to be model over actual? No, but we're just going to do it the same way every problem so that you guys can get it down. Do you guys see that 2 centimeters was the model distance? And 3 centimeters was the model distance? So what am I trying to find out? The actual distance. So here is my proportion. Here's this proportion right here. Do you guys remember how to solve a proportion? Cross multiply. You're going to do 2 times x is 1 times 3 is. Did you guys see where I got these numbers?
Yes.
So 2 times x, 3 times 1. And then divide both sides by 2. You get x equals, and if you make it a decimal, 1.5
Centimeters.
kilometers. And you're like, is that a difference? Yes. I can't do this with kilometers. I can do this with centimeters. So there is a big difference. I can't even try to do kilometers. I'm like, nope, can't do it. Can we link up and maybe? No, still can't do it.
Yeah, you can.
Not here.
You don't have enough people here, man.
Okay.
Will we have the Cherokee mission thing tomorrow morning?
No. There's no meeting this week. It's next week. Good question. And I think that's the same for Bahamas. Then we'll have one every week. Yes, good question.
Why did you put two, like, why did you do 1 and 2?
Right here?
Yeah.
Oh, it's because I had 2x equals 3. And then how do I find out what x is? I divide both sides by 2. So I got my 1.5. So what's the actual distance? It's 1.5 kilometers. Now, how many of you could do that in your head? That's cool. Now, I gave you a nice starter problem, but it does build up to get harder and harder as you get different scales and different numbers. So who can read for me example number 1, Rocky Mountain National Park? Murphy.
Rocky Mountain National Park is about 75 miles from Denver. On a map with a scale of 1 inch and 3 miles, what is its map distance from Denver?
Okay, they gave me 2 things. They gave me 1 inch on the map is equal to how many miles? 30. So that's my scale. We call that the scale. That's the key to the map. And then they gave me that Denver was about 75 miles from Rocky Mountain National Park. Okay, so here I'm going to use proportion. What I'm going to do is I'm going to set up a fraction with this info. 1 inch over 30 miles. And do the units matter? Yes. 1 inch, 30 miles. You're trying to picture, it's hard. 1 inch is not hard. So you got to get the model over the actual. And then I got to set up another ratio, because that's a proportion. Where would the 75 miles go? I got 2 votes, 3 votes.
Bottom.
The top is dealing with the model,
Wait, I thought you...
and the bottom is dealing with the actual. So what's 75, an actual or model number? Actual, so you put it right here in the bottom. And I don't know what the model is. I don't know what the map distance is. That's what they're trying to figure out. Yes,
For
ma'am?
this one, you don't want to cancel out units because I don't see...
Well, you know what happens? We're not dealing, don't worry about the units, but they would cancel out. Like we did on unit conversions. I'll do it on the board later. But don't worry about the units other than you got to put miles on the bottom, inches on the top. And they're not multiplying, they're equaling one another. So there's a difference. How do I solve for x? Cross multiply. What's 1 times 75? And what's 30 times x? All right, and then solve for x. So this is a little equation. And almost all of these are going to have this kind of format, but the numbers get... So I get 2.5. 2.5. Yeah, which one? Inches. We're talking about on a map. How far would Denver be from Rocky Mountain? It'd be 2.5 inches, right? 2.5 inches. So inch, I gotta do this like that. 2.5 inches. In order to be proportional. Yes, ma'am?
Can you explain how you know whether to put 75, like on top of one?
Good question. All right. Do you know how to write the scale factor as a fraction? You just write that over that. Okay. Which one represents the actual distance? The top or the bottom?
The bottom.
Bottom, right? Which one represents the model distance? Top. Okay, so I have the model over the actual. Okay, once you determine that, you're like, okay, did they give me the model or the actual amount? Actual, so that has to go on the bottom. And that's why I wrote that out.
Doesn't it just go where it's buddy is?
Yes. The buddies are inches in this case and miles in the bottom.
Yeah.
That's the buddy. But we understand those as actual on the bottom, model on the top. Okay, but blueprints. Anyone heard of blueprints? Anyone, your parent maybe works with blueprints, something like that? Okay, blueprints. What's a blueprint, Michael?
It's like a sketch or like how you're gonna make like a model.
It's like a drawing
Yeah,
or
a drawing of what you're building or what you're gonna do.
You know, this building right here has a blueprint. So there's, and it's, you know why they call it blueprint? Because a lot of them were printed on blue paper. Not always, but a lot of them. Okay, there's this blue drawing of this building, and this is what I tried to draw. Here's Mr. A's room, and then Mr. Hubbard's room, and then the hallway, and they have doors and windows and all that. But they don't just draw them out. They're like, I think Mr. A's about that big, and then Mr. Hubbard's room, I guess that's about the hallway. How do they actually draw it out? They have to measure it. And it has to be according to, I don't have the word up there, proportion. Like Mr. A's wall should be proportional to Mr. Hubbard's wall, and they measure out what it actually is going to be and what it should be on the drawing so that you're not confused. Like someone can look at, actually that'd be kind of a fun game. Someone can actually look at a blueprint, blindfold a person, and give them direction through like some kind of audio, and so walk 3 feet forward and then turn left 10 feet, then turn right for 5 feet, you'll get to Mr. Thomas's room, for example. They should be able to do it using the drawing, the blueprint. So is the blueprint just some sketch of everything that's going on here?
Yeah.
No, it is a proportional drawing of what's the layout is here. In this case, the blueprint for Selena's new house has a scale of 1 inch to 2.5 feet. Her room is drawn as 4.5 inches by 6 inches. What are the dimensions of the actual room? So they give me first 1 inch to 2.5 feet. So that's your scale. This is my scale. Which number is the actual? 2.5 feet. Which number is the model therefore? 1 inch. 1 inch, 2.5 feet. Okay, so they're saying that the room, Selena's room, is 4.5 by 6. 4.5 inches by 6 inches. Is that the actual size?
No.
That's the blueprint size. They want you to find the actual. Does anyone know how you're going to do that?
Put that in twice.
You're going to work this problem out twice. You're going to get it for the 4.5 inches, and you're going to get it for the 6 inches. I'll work it out once, you work it out the other way. So what's my first fraction always going to be? The scale, which in this case is 1 inch over 2.5 feet. But I need to set up a proportion. I'm going to use the first measurement here. Where does 4.5 inches go? Top or bottom? Top. How do you know it's the top? It's the model. Yep. Inches, feet. So I don't know what that is. I'm going to figure that out. Well, you figure it out first. It's going to get you a certain amount of feet. And feet matters. Because if you don't put feet, we don't know what we're talking about.
Can we just use metric?
Oh, you wanted me to answer that. No. Because we use, unfortunately, our customary system. Metric is a lot nicer, though. We must admit.
Should we if we get point something feet, should we just leave it as that?
Yeah. This one it shouldn't go out too far. If you did the multiplication division right. All right, cross multiplying would be 1 times x, which is 1x. And 2.5 times 4.5 is 11.25. And then you divide both sides by 1. What is the actual length of her room or width of her room? You put 11.25 feet. If you don't put units, how about this? If you don't put the correct units, it's wrong. If you don't put any units, it's also wrong. Because I need to know what units. But then how would I do it with her 6 inches? So it's 11.25 feet by whatever that is.
Wait, can we for by? Then we just put like the multiplication.
You can, yeah. Either way. Did everyone get it? All right, Betsy, what'd you get for the 6 inches, the actual length?
Actual length, I thought it was 11.25.
That's for the 4.5 inches. We converted it to this. So you had to do this process again for the 6 inches. Because they gave you 2 measurements, 1, 2. So it's like 2 problems. Jensen. 15. It's you should have gotten 15. Yes, feet. That is the actual set of dimensions for her room. Who got the 15 feet? Why? How did you get the 15 feet? So this is the second problem. That's the first one. Second one.
I did the 1 inch over 25 feet.
So the same scale.
And equals 6 inches over
6 inches. Well, I mean, but I really thought the 6 goes down here. What's wrong with that? If I put the 6 down here.
the model.
Yeah, the top deals with the model. The bottom deals with the actual. And I'm trying to find the actual. Okay, go ahead.
And then you cross multiply.
Mhm.
So 1 times x, and then 6 times 2.1.
And then we get the correct units, which is feet. So you're just using a proportion, in this case, a couple times. Okay, guys, I want you to do on page 285. Unless there's a question, I'm going to take it. I'm going to take science as no question. I get this. Starting, okay, now. Page 285, on the try these, I want you to do number 2. How far is it actually between Los Angeles and San Francisco? I made that trip many times growing up. It takes us about 7 hours to get there. But I'm trying to not figure out how much time it takes, but how far it is, how long that distance is. So using that scale, that's in bold, find the distance between San Francisco and LA.
Can we use like the shortcut of the other?
What is the shortcut?
So like, if it's top or bottom and wherever its buddy is.
Yeah.
That
But set up a
times what
proportion.
equals that one.
Yeah, just set up a good proportion. You don't have to write everything I write down, but you do need to write a proportion. So what's the first proportion, or first ratio, I should say? What's the scale?
2 inch over 75.
So 2 inches over 75 miles. Okay, that's model, actual.
X over 100.
How'd you, wait, oh, sorry, we're doing number 2?
Oh, oops. So it'd be X over 2.
1 inch over.
So does the 10 go in the top or in the bottom of the next? Goes in the top. Because you have inches up top and miles down low. And then, how do I solve this proportion? Rachel. And what's 75 times 10? 750. So I get 2x equals 750. And then I have to divide both sides by 2. And I get my x equals miles. No miles, no good.
So
Yes, sir.
I just noticed I didn't have to cross multiply because I knew that 2 times y equals 10 over 5. So could I just do that?
On the ones that work that way, yes. Yeah, honestly,
Some of them are hard.
yeah. Some of them are going to be like, what times 2 equals whatever, so you won't know. But cross multiplying will always work, thankfully. All right, your assignment.
Alright.
Yeah, that's it. So calculators, I do need to ask about that. How many of you have a calculator that you can bring tomorrow? You have one, bring it tomorrow.
Yeah, I don't have the fancy.
Yeah, here's an example.
I like destroy.
Do you know how much it was?
I got it at CVS for $20.
$20. Okay, so that's a nice calculator, but I've seen these for $8. So
I got ripped off.
no. But I mean, it looks really nice. Okay.
You got jigs.
And it even can.
CVS.
Yeah, it says scientific calculator. So, listen to me. Okay, please listen. And I'm putting this on spool because I want you to know. You need next year a graphing calculator. So if you can get a graphing calculator for tomorrow, then I would do it. But you don't have to. Please don't say, Mr. A said we must get a graphing. That's $120. He wants it by tomorrow. I didn't say that. Okay, but you need at least a scientific calculator by tomorrow, and if you don't, I'll try to bring some, but I don't have. You may get a $5, but that's not on me. I did not say to get a wait, 500? No, nothing above 300.
5,000.
That's just a computer.
Yeah, a nice computer, by the way.
What
Yep.
if you have a graphing calculator at home?
You can bring it. You can bring graphing calculators, but
Okay, if you have one.
yeah, from tomorrow on, because I got pushed back because of my sickness. Okay. Oh, your assignment. Sorry.
You never written it out today?
Excuse me. Begin. And goodbye, Swivel. I'll see you later.